Next, this is a detailed drawing for the pipe. You see, this pipe is connected from indoor to outdoor. No? Here is a section. This is a, you see, the bigger is a suction line, the smaller is a liquid line, and both is insulated in separately. You see, separate insulation for this pipe, separate for this pipe, and on that you may find 3-inch PVC conduit or a separate wrapping, and you can find the cable also, which will connect from indoor to outdoor. So in some models, the power connection to the indoor, from that the supply of power from indoor to outdoor, or in some model, the main supply to the outdoor and the indoor will receive the power from outdoor. So mostly in actual practice in present market now, you will find the power you'll find the models with the power supply to the indoor and from indoor the supply to outdoor. Okay, so it can be in reverse also as per the model, but commonly indoor to outdoor. So that's the reason we required this cable also. So all this complete is going to, as per standard, is going to run with the 3-inch PVC conduit. And if it is running on the roof or on or above fall ceiling, this should be with the separate drain tray. You see GI tray as per standard. Generally, we are not using all this in detail, but as per standard, this is required. For standard project, you must follow this, all this detail drawing for means they will do the inspection. Next, apart from this, you see, this is the base for outdoor unit. You must construct this concrete base, and this before connecting, we require this isolators, nothing but rubber pads to reduce the vibration from the unit to this concrete base. This is as per standard, and from the manufacturer also you'll find this vibration isolators so that they can install on site. Next, now if you talk about the capacity for this split system in the market, available with the 1 TR up to 4 TR, again depend on location and the vendor, means the make. Most commonly 1 TR 1.5 to 2.5 is available. Above 2.5, 3, 3.54 you'll find in cassette, not in high wall. Commonly depend as per the location and the make. The same is given here, 1 TR to 4 TR. You see 1 TR to 4 TR, I'm just combining all the types. But if you specifically talk about the high wall most commonly available up to 2 or 2.5 TR. Next, now if you talk about the advantages for this high wall, you see, look nice in interior. Compare with what? Compare with the window. I'm not compare with the cassette. If you compare this with the cassette will have further advantage. But at this level, I'm comparing this with the window. So if you talk about window, look nice in interior. Low maintenance. Anyhow, no, even for window also we have low maintenance. Low initial cost. Compare with what? Not compare with the window. Compare with the ductable split, the next units. Because usually means it is available in market with the 30 to 50,000 for 1 to 1.5 TR. Depend on the EER also, energy rating. Next, no window space needed, like window AC. For window AC, the opening is required. No? Without that, you cannot install. But this high wall, we can install on any wall in the room. It's not must, it should be the exposed or opening. Next, easy installation. Again, easy installation, not compared with the window, compared with the other central types like ductile split or VRF, etc. Anyhow, skilled technician is required for this, that you'll find in disadvantages. You see, the major disadvantage in this is ventilation not as per ASHRAE or not as per standard. We are following ASHRAE in this training program. So we use this ASHRAE standard. But if you are concerned using Curie standard or any other standard, we don't have ventilation option in this, no? Because the room air, you see circulation of the room air only. There is no addition of what? You see, the same air circulate. There is no option for adding the fresh air. So this is the one major disadvantage in this. But to overcome this, one can open the window partially. We can open the window so that the fresh air will introduce, because this is for small rooms, no? And generally for small rooms, you'll find the windows which will open to the outside. For large space areas with the multiple spaces without windows, if you use this means that will definitely affect to the health, because you know ventilation, the importance of ventilation already we discussed at the starting session, maintaining the oxygen level. So the major disadvantage in the window or in split is what ventilation is not as per standard. Next, professional installation is required. The professional is required. Compare with the window. For window is like a plug and play. In that also the installation person is required, but for this a professional is required so that after installation he can connect the copper pipes to indoor to outdoor with the brazing, and he can check the leakages between the pipes, and he will release the refrigerant from the compressor. And if the copper pipe length increases above say 25 to 30 feet, then additional refrigerant charging is required. So all this can be done with the professional technician only. Next, noisy outdoor unit. Anyhow, if in some project you'll find the objection from the neighbor, or suppose if it is a hospital or a court nearby. So with the outdoor unit noise, they may or you may have the objection from the neighbor or as per the application. So if you talk about outdoor, yes, noisy, because the outdoor will create noise. And limited air distribution. This is also one disadvantage. Not only in high wall, even in window also you'll find poor air distribution because the supply of air from this outlet. So if you talk about definition of air conditioning, motion and distribution also one parameter. But in this, we are supplying the air from one outlet, from one side of wall. So the distribution of air also is poor in this. This can overcome by using a ceiling fan, what we are doing in actual practice in India or even in Gulf. So with the split AC, we are using a ceiling fan. So ceiling fan will help to circulate the air, and this FCU, high wall FCU, will provide the cool air. But you see, the advantage is the cost. No, the cost is less compared with the central air conditioning system. Compared with that, is very low in cost. So this is about high wall split, the first type. Next, we'll talk about the second type, which is a cassette. You see, if you talk about cassette, high wall or freestand, as I said, the working principle is same, but the type of FCU is different. So the second type is a cassette. But before this, we have some more important points for interview point of view. As I said, you see this suction, discharge, and standing pressure. This is generally for the service side, but very common question. This is very common, may ask in interview. So at least you should know for this common type of refrigerant. You see, common type of refrigerant in market is R22. R22 is what? HCFC. In some countries, it's totally banned, but still in many countries, this R22 is used, which is belongs to HCFC with the chlorine content. But compared to HFC, it's less. Then R32, R410A, and R134A all belongs to HFC. And you know what is HFC? This environmental friendly enough. So what is the suction, discharge, and standing pressure? You can relate this. Suction means what? Suction by which component?
Compressor.
By the compressor, right? So suction after this means the refrigerant flow from indoor to outdoor. No? So the flow of refrigerant from indoor to outdoor means it is at low pressure and low temperature, right? So you see the pressure at the suction side. Just for example, if I take example of say R22, just for example, I'm taking this R22. You see suction side is 60 to 75 psi. Compare with the discharge is less. Discharge means nothing but after compression. Na? So you can think after compression, compressor is used to increase the pressure. So this is before compression, and this is after compression. So 60 to 75 psi for R22, and for discharge pressure is in between 200 to 250 psi after compression. Then what about the standing pressure? And you see the suction and discharge pressure is based on when the machine is running, and standing pressure when the machine is off. Okay, in between 50 to 80 psi. And this 50 to 80 psi, I'm talking about the low side, not the high side. Again, high side, it is going to be in between 150 to 180 something. And this pressure, suction, discharge, or standing pressure is first point is for R22, and the second point is based on this temperature, based on this room temperature, 21 degrees centigrade. If this room temperature increases or if this refrigerant changes, this pressure also will change. Okay, so this is just, you see, this is just for interview point of view. In actual practice, this pressure rating will vary based on the ambient temperature or the room temperature, and also based on the refrigerant temperature. For interview point of view, you can just memorize this 4 refrigerant, which is as per standard condition.
Can you explain standing pressure once again?
Standing pressure means the pressure, the this pressure at low side when the machine is not running, and all this pressure at this temperature, 21 degree centigrade standard for learning point of view. So remember, this pressure rating will vary based on the based on the ambient temperature and also based on the refrigerant. So you can relate this. You see, for R32 compared with R22, this pressure is different. And you see, for R130, 134, the pressure is less compared with the R22 or R410A, this suction and discharge line. So this pressure rating also depend on the type of refrigerant. So this four refrigerant commonly used in actual practice for split window, even for chiller. In chiller, you'll find 134A or chiller VRF, and package you'll find 134A or 410A or even R32. R22 you can find in window and split only, not in the big units. Next, apart from this, some more important points. What I explained, the suction and discharge line, why the difference in the dia. You see, the suction line typically larger in diameter. The reason is what? You see,
Vapor.
lower density and higher volume compared to the liquid refrigerant. And the liquid line is smaller. The reason is, you see, density and less space. Density is higher and the less space is required. Okay. And this diameter, the pipe size you'll get from the vendor, like 1/8 for suction side, 1/2 inch for this liquid line, etc. And this dia will change as per the capacity also. So you can find this dia from the machine catalog. Next, some more terms may ask in interview. Remember FLA. In short, we used to call FLA. It's a full load ampere. So what is full load ampere? Remember, when the compressor running at full load, the current drawn by the compressor is called FLA. Simple. Next is a LRA, lock rotor ampere. Nothing but starting current. And remember, LRA always more than FLA. So what exactly LRA? I think you can notice when you switch on the refrigerator or when you switch on the AC, for few seconds, you'll find the fluctuation because starting current is high. Why starting current is high? Because the compressor in the lock state. I'll give you a simple example. When you run a bicycle, for first pedal we require more force. After that, you are in the running. So the first pedal force you can consider as a LRA because the compressor is in the lock state. To start that, higher current is required, even more than FLA. Once you start, then if it is running at full load, it will draw FLA. Or when it is running at a normal condition, then RLA, rated load ampere, because the machine will not run full load at all the time. Na? Okay, so when the machine is running at the normal condition, that it will draw the current. That current is RLA, rated load ampere. In some cases, RLA, FLA is going to be same if compressor with the same speed. But now we have the inverter and the variable speed compressors also. No? In that case, FLA and RLA is going to be different. Okay, in the same speed compressor, FLA and RLA we can consider same. And LRA is common for all the types because that's starting current. And this may ask in interview, very common terms. Next, one more important point, the copper pipe length limitation with almost all the manufacturers except some high class in between 25 to 30 in general. Again, this length will vary as per the position of the indoor and outdoor. For example, consider a building. Suppose if I place the outdoor on the top and the indoor is here. Okay, this is one case. The second case, for example, the outdoor at the bottom means on the ground and is connected to the indoor. This is first case, second case, or in third case, for example, the outdoor is on the top and the indoor at the bottom. So this copper pipe length also vary as per the position of indoor and outdoor. So if you place on the similar level, for example, just above that floor, if you place the outdoor, we can maintain the length up to say 15 meters, means 30 up to 45 feet. And in this case, you see, we can go for 15 feet. And if the outdoor is on the top and the indoor at the bottom, we can consider nearly 20 feet. So this is the approximate, and the exact you can get from the vendor. from the manufacturer. Okay, so in general, for interior point of view, the copper pipe length for split system is going to be 25 to 30 feet. And
This is
generally, in from the vendor, when you purchase this in the box, you'll find 10 feet copper pipe. So 10 feet is a standard. When you purchase with the split AC, find three boxes, one for outdoor, one for indoor, and one for the copper tubes. In that, you'll find the standard length as 10 feet. If you want more, you need to purchase additionally, and you can do the brazing on site up to say 25 to 30 feet.
yes, sir. This is total pipe length for the loop or one side, like suction side or
No, no,
this.
combine. I'm considering this as one pair.
Okay,
Indoor suction and liquid, not individually.
okay,
Suction and liquid we'll consider as one pair.
one loop.
Next we'll talk about the cassette. This is the second type, split AC, and this is a ceiling suspended type.
Sir,
What we discussed just now. Yes.
what about the location of the outdoor? If outdoor is above the indoor, height difference means our outdoor is at the ground and indoor is at the top. So flow of refrigerant gravity effect is there.
No, it's a closed system, no? It's a closed system. Anyhow, other parameter will affect. So that's the reason the position of this unit is important. And according to that, from the vendor catalog, you'll get the exact information. Next we'll talk about this cassette. This is the second type. You see, the concept is same, but the type of FCU is different. What we discussed just now is a high wall type, but now the type of FCU is going to be cassette. You see, the cassette air conditioner, often referred as a cassette AC or simply cassette system. It's a type of AC commonly used in commercial and some residential, mainly for interior point of view. Mostly as per the interior requirement, will go with the cassette type. So how exactly? You'll get the clear idea in this video. So let me just play this. Please have a look. You see, this is the front panel of cassette. Only this portion is visible. The complete assembly is above the false ceiling, and this is a false ceiling level. And this middle portion is for suction, and these are all for supply. In most of the model, you'll find four side supply. In Daikin, you'll find the round flow. So they are offering opening in this also. So they used to call round flow. Anyhow, compared with the high wall, we have advantage of a distribution in this, even if it is a four-way site. But in
But
cassette,
I can say
they
that.
have
Okay, let's continue.
in cassette we have four outlets, but in Daikin model they are offering the round 360. So they are offering the opening here also. In the video, you'll find this. You see, this is a cooling coil and blower, suction and liquid line. The blower at the center, and the cooling coil construction is round. Compared with the FCU is different, and suction from the middle grill, and it will throw on this, so the air loses the heat and the moisture and come out from this outlet, four outlets, as cool and dry air. This is a modification from Daikin. You see, this is a suction grill, and these are all discharged. you see, you'll find this evaporative coil. So on the evaporative coil, condensation will happen. So water is going to be collected at the bottom, and this bottom we can call as a drain tray. Find the passage for collection of water. But the important point in this, like high wall, we cannot connect the drain pipe because this is going to be installed in the ceiling. No? In high wall, it is going to be on the wall. So through wall chipping, we can take the drain pipe below the level of that unit so that we can maintain the gravity to throw the drain water out through this U-trap. But in this case, I cannot take the pipe below the level of this unit because this is the ceiling suspended. So remember, in cassette FCU, you will find the drain pump. So as per the level of water, when the water start collecting at the drain tray, after some time when the level increases, a drain pump will suck the water and will throw in the drain pipe, and this can so that the drain pipe can connect above the level of this unit. You'll find in this part. It's a drain. This is a drain pump. Sorry, this is a blower. First, after blower, you'll find the drain pump. You see above this evaporative coil and below the collection of water. This is a drain tray. You see in this model, we can connect the drain pipe 850 mm above this unit. And this may vary from vendor to vendor, make to make, but definitely you'll find the drain pump in all the cassette, and one can connect the drain pipe above this unit level. Rest of the concept is same as split. Again, this will connect to the outdoor with the suction line, liquid line, with the insulation cabling, same as the high wall. Can you see here one detailed drawing for installation? This is the installation for indoor unit, and these are all anchor fasteners, which is used to connect this full threaded rod. And this full threaded rod is connected to the indoor unit, and in between you'll find the isolators or a rubber, which is used to reduce the vibration from the unit. So these rods are full thread rods, and these are anchor fasteners. I think you know what is anchor fastener. Commonly used even to install the fan or even for the duct or for the pipe. Anyhow, if you don't worry, at the time of duct and pipe installation, you'll find more about this anchor fastener. So mostly this is as per the interior requirement because it's look nice in interior. I'm not comparing with the window, I'm comparing with the high wall. Even compared with the high wall, the appearance is good. You see, it enhances the interior decor. So mostly in restaurants or in office or in high class villas or in showrooms, you'll find this because the appearance point of view is good. And for air distribution point of view also, can expect the uniform distribution of air compared with the high wall. And it's a ceiling suspended, and the unit is not visible in the space except that panel. Only the panel is visible. The complete unit is concealed. But in case of high wall, the complete unit is the indoor, this FCU is visible. Next, internal drain pump, what we discussed just now. Disadvantage, cost. You see the cost is higher compared with the high wall for the same capacity. For example, if you purchase 1.5 or 2 TR high wall, compare with the cassette, you can expect 25 to 30% higher in cost. Okay, because the manufacturing of that coil, the coil shape is different, and the unit. So mostly cost point of view, this is expensive. 25, nearly 25 to 30%. Installation can be complex. Complex means they need to align with the proper false ceiling. Sometime or many time you'll find the gap between this panel and the false ceiling. So they must take care of this proper level, and this drain pipe they must connect without any leakages. If any leakages from the drain means that will damage to the false ceiling if it is a gypsum board, or it may affect to the electrical issues in case of this leakages of water. And drop ceiling is required anyhow. With the false ceiling only we are using, so we cannot consider this a disadvantage. Without false ceiling we'll not use this. So with false ceiling, as per the interior requirement only, we can use this one. Next, condenser drain may need attention. Means proper this drain is required because this is going to be above that unit level. We cannot take that pipe above the level which is given in the machine catalog. Suppose 850 in the video, now above that, if 850 if you take, the pump is not will not be sufficient to reject the water out. So you must maintain that level as as per the catalog from the vendor. You cannot take above that. Recommended to use below that only, at least 25 to 50 below as per the catalog. Cannot go above that. Application, what we discuss. Selection as per the interior or the client requirement, or sometime as per site condition. Sometime you'll not get the clearance on wall. The wall is occupied with some interiors or some almara, or some in office you'll find some rack. So if you not find the enough clearance on the wall, we can go with this. Or else, mostly in actual practice, most commonly this is as per the interior requirement, interior point of view, because it just looks nice in interior. And we have a technical advantage also, uniform distribution of air. So this is about the second type cassette. We have one more, that is a tower or floor stand. So let me quickly complete this, because this also same type, means split only, but the type of FCU is different. So in some project, you may not get the clearance on the wall, or you may not get the clearance even in the false ceiling, because false ceiling also with some interior design with the lighting, etc. So they may not provide the clearance. In that case, we can go for this tower, you see. So remember, this also connected to the outdoor unit. This is not this is not like a air cooler. We cannot move after installation. Once you install, the copper pipe you can find at the back side of the unit, which is going to run towards the outdoor and connect same like the high wall. Only the difference in the high wall, we are going to place the FCU on the wall, and this is the tower type, the floor mounted. So if you talk about advantages, for example, you see in this case, this wall completely is of glass. So there is no option for high wall. Similarly, you will not get the clearance on the wall. In that case, we can think for this. Or else, most commonly in actual practice, if the client decide to go for installation, or decide to go for AC after completing the interior works, in that case you can suggest this option. Because you see, after completing the interior, if the client, or if you suggest cassette, you need to damage the false ceiling and the wall chipping. Or else, even for high wall, you need to do the wall chipping after completing the interior paint work. Again, if you try to install the high wall, you need to go for damaging that wall chipping and all, etc. In that case, one can suggest this one. Or else in case of old project, if you want, or modification or retro type, one can suggest this one. Okay, so depend mostly as per the site condition, or as per the interior. You will not find this commonly. Most commonly, you will find high wall or interior point of view cassette. In some projects, you may find this, or you can suggest as an engineer as per the situation. And you see, okay, let me complete the advantages first. You see, advantages: it can be installed after completing the interior work. It can be used in the situation where no ceiling is required, means without false ceiling, because it is not require any ceiling. Na? Suppose there is no false ceiling, so one can use this one. It can be installed after completing the installation work or interior work, as I've given just now. Now, if you talk about disadvantage, even compared with the cassette, the cost is high for this, because you see, you'll find the tall body unit, so the metal cost and all this. So the costing point of view is higher, almost 40 to 50% higher compared with the high wall. Okay, if the high wall, if you get in 50,000, say 1.5 TR, for this high wall, you need to spend 70 or 80,000 for this high wall. So because this is not commonly available also. So cost point of view, then you see, it will capture the floor area. Anyhow, if you're not going with the cassette or high wall, we'll go for with this. So if you have enough space on the floor, then only we'll use. So anyhow, when you install this, you need to provide some space on the floor. So for commercial spaces, you may find the space consideration. Next selection, as I said, as per the client or interior requirement, or as per site condition, or the clearance available, or if the client is interested to install after completing the interior works, the same point. So this is about the split air conditioning system. Apart from this, you may find the other models like ceiling suspended. I'm not talking about cassette. You'll find high wall type in the ceiling suspended also. Or else if you talk about cassette, in the cassette, what I explain is a four-way. You may find two-way cassette or one-way cassette also. Different models are available in FCUs with the split system. Apart from this, you may find the floor mounted unit, a small floor mounted, not commonly used. So the list of models you may find with the different catalogs, but most commonly in actual practice, high wall, cassette, and if required, freestand in split system. So this is about split air conditioning system. Let me continue with the ductable split, which is a part of a central air conditioning system. So first we'll discuss what is central air conditioning system. Just overview. In detail, you'll get the idea when we talk about the different systems. You see, if you talk about the window and split, window and split comes under unitary. Unitary means the unit wise, means or room AC. But if you talk about this ductable split package, VRF, chill water system, or radiant cooling, or we have this geothermal. Anyhow, geothermal is the source. All comes under central air conditioning system. The concept of central air conditioning system is the machine we are placing somewhere inside the building. If it is AHU, or if it is a package somewhere outside the building, and from that point we are supplying the air to multiple spaces or different spaces. This is just in general. Again, depends on the type, the system. You'll find the different indoor, outdoor, or if it's a package, you'll find the single unit. But the concept of central air conditioning system is we are placing the unit and the equipment in a particular place. From that point, we are supplying the air to the different spaces in general. Again, if you talk about VRF, the case will be different. And again, the ductable package. So you'll find the changes as per the location of the units, or as per the depend on the type of system. Okay. So if you just compare in general way about the unitary and central, unitary means room AC, one room, one machine. But central means one machine, multiple spaces in general. Okay, at this level. So you'll get more idea when we talk about this different types which comes under central air conditioning system. So in the list, first you'll find ductable split. Ductable split air conditioning system. This is simple because we already discussed about the split system now. So here you can find, you see ductable split, you can consider as a bigger version of what? Of split. It's a bigger version of split, and we can add the ducts to the unit, and this unit is called AHU, and we can provide the fresh air. How? I'll show you, don't worry. Just let me give you the idea first. So the first important point related to ductable split, this we can consider as a bigger version of split. The second point is it can, or we can connect the duct and can provide the air to multiple spaces, and we can also provide the fresh air as per the requirement, as per standard. So how? We'll discuss in this system. So first of all, let me show you some images. This left side, in general, we can call this as AHU. Okay, this is called AHU, air handling unit. And remember, this AHU can be a part of ductable split. It can be a part of VRF system, and we can use this even in chill water system. And we have a separate topic for FCU and AHU. Let me complete this system, then we'll discuss in detail, because this unit is common for multiple systems. At this level, this is AHU, or we can call indoor unit. You can find in this image also, you see this we can call as a indoor unit, or in general, this is a AHU, and which will connect to, you see, condensing unit. So this is like a split system, but ductable split. Why we are calling ductable split? Here you can see we can attach the duct. And with this duct, we can provide the air to multiple spaces as per the requirement based on the capacity. And we can provide the uniform distribution of air, and we can also provide the fresh air. How exactly, I'll show you, but the concept is simple. You already know this the split system in what are the components in indoor and outdoor. Already we discussed the same thing, but the capacity is higher, and we can attach the duct. With that, we have some more additional options. So let me show you with the line diagram in the next image. And you see this below is called, we can call FCU, or this is specifically conceal FCU. What we discussed in the previous session, high wall, cassette, freestand. If you talk about if you talk about as per the type, all are FCUs only. The high wall which you can place on the wall, there is a type of FCU. The cassette indoor, what we learned in the previous session, that also FCU, or the freestand, the tower type, that is also a FCU. Similarly, this is called conceal FCU. So this FCU and AHU is common for multiple systems. Okay, at the time of hotel project, I'll show you this. So you see, these types of indoor is depend as per the interior requirement, or as per the site condition, site clearance, or sometime as per the client requirement, etc. Okay, so you'll have multiple options in this. And you see, what we discuss is a few types of FCU. You may find one-way cassette, you may find two-way cassette, you may find floor mounted FCU, you'll find ceiling suspended FCU. Like high wall, you'll find the ceiling type also. Again, concealed ceiling type also. So you'll find number of options or different models in actual practice.
Sir,
So
in
I'll
my
show you
mind,
that. I'll show you one catalog. In that you'll find different types, but it's too early to discuss. So ignore this. Just at this level, remember, this is actually, in short, just to avoid confusion, small units capacity below 5 TR, we used to call FCU. Above 5 TR, we used to call AHU. Technically, both are same. Okay, but capacity point of view, the name is different. Apart from this, you will find additional options in the AHU, like humidifier, dehumidifier, or a heater, or a additional filter, etc. That depends as per the application. But technically, in both, you'll find evaporative coil, you'll find the fan. Both is for cooling, means you'll find the cooling coil in this. And the major difference, anyhow, we have a topic. I'll cover all the points what I explained with more details at the time when we deal with the topic called FCU and HU. And similarly, we have a topic called DX and chill water system. What is the difference between DX and chill water system? Okay, so back to the topic. So you see how this ductable system works. Very simple. Everyone aware of this split system, na? And what are the components in indoor and outdoor? The same thing in this, because it's a ductable split. So this outdoor unit, this indoor unit, but this indoor unit is what? It's a ceiling suspended. We can hang with the anchor fasteners like this, and this is above the false ceiling, or it can be without false ceiling, open ducting. You'll find in some supermarkets, it is visible. So the indoor type is with the indoor with the option to attach the duct, because it's a ductable. And here in outdoor, the components, compressor, condenser, the same cycle. In indoor, you'll find the cooling coil and the blower. Apart from this, you'll find the filter here, and you'll find the one more pipe for the drain. And again, drain with the U-trap is required. So the same thing. So the new option you see here, we can attach the duct. And what is duct? A duct is a sheet metal box which is used to convey the air. Okay, or in short, we used to call air conveyor. And we have a separate topic for this duct system in part 4. After this we have a separate air system, part 4. In that, we'll discuss more about, or in detail about, this ducting. At this level, just quickly let me show you some images. If you're a beginner, this will help you just to get some basic idea. You see, all these images belongs to the duct. You see the sheet metal box, which is used to convey the air, or is going to connect like this. You see, here's the unit. This is, we can call, say, FCU, conceal FCU, to which the duct is connected. And for this duct, again, we have a canvas cloth, J terminals, lot of things that we'll discuss. We have a separate story for this. At this level, just focus on the concept. Okay, so now here, the first option, we can attach the duct. So you can find here the duct is connected, and to which we can connect the A terminals, like supply diffuser, and with the supply diffuser, the cool air with the duct, it can supply to the space, and again return from this return air diffuser and this return air again to the suction of this unit. And if the blower is supplying the air, means without suction it's not possible, no? So this blower will suck the air and throw inside this duct, and in between you'll find the cooling coil. So you know this procedure for the cooling, and you'll find the cool and dry air, and at the bottom you'll find the collection of water, so drain and drain of water with the U trap, all this, you know. So first point is the capacity is higher, and if you want we can continue this duct. You see, this is say space 1. I can continue to space 2, or I can continue this to space 3 as per the required capacity. For example, 5 spaces, total requirement is say 10 TR. So for example, as per load calculation, for example, so I'll go for the 10 TR capacity ductable split. And with the duct, I can supply the air to all 5 spaces. But remember, 1 AHU means 1 thermostat, 1 control. So number of spaces is going to 5. So here 5 spaces, but zone is going to be 1 because only 1 thermostat, na? Because controlling is 1. Okay, so if all the spaces, timing and temperature is same, we can connect with a single unit. If you want multi-zoning, we have alternate options with a CAV or with a VRF, etc. That we'll discuss later. At this level, just try to understand the concept of ductable split. So here we can attach the duct. Second, so first point is the capacity. Second is a duct. We can attach the duct, and we can provide the third point. We can provide the fresh air. Fresh air we can provide with the multiple ways. Okay, here I'm going to cover one option. Later, at the time of load calculation, at the time of heat gain through ventilation, we'll discuss the different types of options to provide the fresh air. At this level, I'm covering just one option. You see, I can use this call piece. Call piece means a piece of duct which is bent down, and here you'll find the mesh. And this piece we need to design as per the fresh air requirement. For example, total CFM for this unit, say 5000 CFM as per my calculation, as per the load calculation, and 10% of this, okay, pressure I'm providing. So 10% of 5000 is 500 CFM. Okay, and remember when I use this term 10, when I use this 10% or say 10 to 30% fresh air, remember this is as per thumb rule. Okay, so for interview point of view, we can use this when they ask the requirement for fresh air as per thumb rule is 10 to 30% for commercial and residential spaces. Commercial like office, school, mall, etc. Residential, you know. This is just as per thumb rule. But we have a detailed calculation as per standard. The standard can be ASTRA 62.1, or it can be a carrier standard, or it can be Dubai Municipal, etc. as per the location or authority. And ventilation is very, very important to consider. So remember, this is just as per thumb rule. So for example, I'm considering say 10% fresh air. So according to that, I'll design, according to this 500 CFM, I'll design this piece of duct that we used to call piece or hose neck, you see, which is bent down, and this is bending down so that in case of rain, the water should not enter inside. And with a mesh, because here you'll find the negative pressure because the suction of this suction from this unit, so you'll find the mesh also so that the outside items will not enter inside. Okay, so you see call piece with a bird net and a VCD. VCD we used to call, in short, we use a VCD is a volume control damper. Like at this level, you can consider like a valve in the pipe. So in the pipe, you know, everyone know as a mechanical valve in the pipe we used to control the flow. Similarly, in air side, we used to call VCD the handle, which in you'll find opening or closing like a valve. In detail, we'll discuss at the time of air side what is VCD, what is manual VCD, what is motorized VCD, what are the different dampers, etc. At this level, I'm not explaining because here the point is to explain what is ductable split and how you are providing the fresh air. So you see, I'm going to design, listen, I'm going to design this 500 CFM piece so that say supply of 5000, out of which 500 is a fresh air. So return is going to be here. Suppose suction is 4500, 500 collection from here, again 5000. And the additional, and the 5000, sorry, 500 what we are adding as a fresh air, that we need to exhaust. Okay, so generally Technically, if you talk about exhaust, we require a exhaust fan or a opening for exhaust. But in actual practice, if it is a residential or if it is a office, you'll not find the separate exhaust fan, because whenever you open the door, because of positive pressure, the exhaust will happen. Okay, we'll discuss more about this fresh air exhaust system, how to balance and all. At this level, we are providing say 500 CFM fresh air. The remaining from the return, again 5000 supply through this duct to the spaces. Got the idea online about this ductable split? The concept of this ductable split system. The first point is what? Bigger. We can consider as a bigger unit of split. The capacity start from 3 TR up to 25 TR in general. If you talk about carrier, we have available up to 17 TR. Sorry, 16 TR. In Blue Star is available up to 17 TR, and as per the make and location, this range may vary. In general, we can consider 3 TR to 25 TR. The first point. The second, we can attach the duct. How we can attach the duct, you can find on the screen. And detail about the ducting, we have a separate part. Next, we can provide the fresh air. In the previous systems like window and split, there is no proper option for fresh air. In window, in some model, we have option for fresh air, but that is not as per standard. In a split high wall or in a freestand or even in cassette. In cassette, we can provide, but again, as if you talk about split, you'll not get the proper option for the fresh air. But in case of this ductile split, since this unit is placed above the false ceiling and say concealed unit, we can use the duct to provide the fresh air at the suction of this unit as per the standard, as per the requirement based on the calculation. For just for thumb rule, what I explain is 10 to 30%, but we need to do the calculation for this. According to that calculation only, we'll provide the fresh air. And we have a separate calculation for this at the time float calculation. Next, we have some more points to discuss. You see, about the drain U trap, the same concept is applicable for this also. Here at the bottom, we need to connect a drain pipe, and we are connecting to the nearest flow drain, but don't forget to connect the U-trap. You know the importance of U-trap. And this copper pipes, it should be insulated. Again, you'll find the cabling. Cabling generally you'll find for the outdoor. Depend on model also. In some models, you'll find the cabling for indoor and indoor to outdoor, or main supply to the outdoor, and again supply from outdoor to indoor. That depends on the model. And both the pipes require insulation. Even this one more point, this drain pipe also required insulation. Why? Because this drain water is a chill water, na? And if it is running inside this pipe which is above the false ceiling, what will happen? The surface of that pipe, on that you will find the temperature less than equal to dew point temperature. So condensation at the surface, na? So what will happen? The droplet of water is going to be fall on the false ceiling or on the electrical item, so that may create a short circuit or damage the false ceiling. So even this drain pipe also required insulation, because this drain pipe in this image here you can see the outside wall, but this suppose the room is extended, so the drain pipe will run it will run maybe 10 feet or more than that with the proper slope. So insulation is required for this drain. And if this drain pipe is running above any electronic equipment, like suppose it's passing through the server room or any electronic, we require that even the drain tray also below this what drain pipe for additional protection with insulation. First insulation on the pipe is required, then apart from this the drain tray also required. And even this, if this unit is placed above any electronic equipment, below the unit also we required one drain tray for additional protection. So now you see the capacity what I explained, 3 TR to 25 TR in general. Here one example is given as per carrier. In carrier, you'll find up to 17 TR with this different configuration like 3, 4, 4.5, 5.5, etc. In 11, you'll find two models with a different RPM, with a different, with a different CFM. So depend as per the make, you'll find the multiple models with the same capacity also, as per the size of the unit, which suits site condition, etc. Next, what explain the same, ventilation as per standard is possible. Can be whatever the standard you're following as per your consultant. Central air conditioning system. And you see, it's a concealed unit, will not affect to the interior because above the false ceiling, so it's not visible. Even if you see some interior will not accept even high wall FCU, because that hiver also will appear in the space. No? So as per interior requirement, they may not accept that. So they ask for a cassette or conceal. Next, low noise. Low noise. First, the outdoor unit is outside, like seamless split, and even the indoor unit also, not in all the spaces. No? For example, you see this unit is placed here. So you'll find the noise for this room, but for other rooms, you can expect low noise. Anyhow, you'll find the different models in that. If you're very concerned about the noise, you'll find the high class model also. Even in the indoor conceal unit, you'll find the very low noise. But anyhow, if you for this room, for example, for this is considered as space one. In space one, you'll find some noise because of this unit. Not like compressor, but still you'll find noise because this fan will run with this high speed and it will supply the air to the multiple spaces. So you cannot expect the very low noise. But in other spaces, yes, you can expect low noise. And since we are using the duct, so uniform distribution of air can be achieved. And uniform distribution of air is also one of the parameter for air conditioning, motion and distribution, and the noise level. So with the help of duct, with the uniform, the air terminals, one can provide the air, or one can distribute the air uniformly to maintain the comfort. Okay. Now, if you talk about disadvantage, you see installation complexity. Compare with what? Compare with the window and split. We required installation of duct, proper sizing of duct, installation of duct, and the A terminals, etc. Compare with the split. I'm saying, not with the other. Next, initial cost is high. Again, compare with the split system, because separate low side work, means ducting work is required. That also increase the cost of the project. Maintenance, because you see this unit is concealed. Anyhow, in actual practice, below the unit in the false ceiling, you'll find the trap door. Trap door is for maintenance. In case of grid false ceiling, I believe everyone know what is grid false ceiling. Yes, online.
Yes, yes,
Grid
sir.
false ceiling means you'll find the tile, or tile false ceiling. You'll find the pieces of tiles. Na? So in case of tile false ceiling, easily one can remove the tile, and if any maintenance can be achieved. Or in case of in case of gypsum false ceiling, you need a trap door. You'll find the separate trap door in case of any maintenance or changing of filter, etc. is required. So maintenance required the proper access. Compare with the split system. Next, loss of ceiling space means in some project you'll not find enough space above the false ceiling as per the interior requirement. So in that case, you need to compromise to maintain this height of this unit. Okay, and this height of the unit you'll find from 9-inch to 24-inch, depend on the capacity. Okay, so if it is say 17 TR, you need to compromise 2 feet of this unit above the false ceiling minimum. Okay, again, above and below also some clearance is required. So you need to compromise with the false ceiling. In case of a limited false ceiling, this option is not applicable. Not only because of unit, because of duct also. If you don't have enough clearance above the false ceiling, nothing but space above the false ceiling, you cannot go for this ductable system. You can go with the VRF. So what is VRF? We'll discuss. Let me complete the package first. Next, application. You see, this ductile split most commonly you'll find in Indian market. You'll not find in Gulf or in other regions. Commonly, it's available, but commonly in Indian market, if you go to any if you go to any DMart or Vishal Mega Mart or DMart or this Big Bazaar or different showrooms, you can find this ductile split, because this is commonly used in India for medium type of stores, even in residential also, in case of a single zone. So in restaurants, you can find out this. Villas, not commonly, but in some projects, hospitals find, and most commonly in supermarket. If you go to any Reliance Fresh in India, you can find this ductile split. Okay.
Sir, in the hospitals, most of the hospitals or big hospitals, I can see that
No, I'm
they're
not talking about
using.
big hospital, the medium type. In big hospital, you'll
And
find the air cooler, water cooled chiller.
in
Okay.
corporate office also, looks tough to fits that, because we have separate, meeting rooms, board rooms, something like that.
Hmm.
So we have needs that separate controls for
You see,
that rooms.
please don't do the conclusion. In one project, you may find multiple system. For example, corporate office means, like for example, 10 office cabin and a
Mm-hmm.
open office, and
Yes,
the
yes.
timing and temperature is same for that.
Mm-hmm.
Assume that for 10 cabins, which is belongs to employees, and an open office, so timing and temperature is same. So we can connect all this with the ductile split. Remaining we can deal with a split system or with the VRF. So you will find the multiple options also in one project. Okay, it's depend. I'm talking about, you see, if I talk about ductable means is applicable, is available up to 17 TR na, one
Mm-hmm.
unit. So you cannot, I'm not talking about the big projects. If you talk about a big hospital or a big corporate office, a large area, will deal with the chillers. Okay. So here supermarket, for example, take example of Reliance Fresh. Reliance
Mm-hmm.
Fresh area is not a big one na, or a DMart. I mean, I'm just come if you compare with a high rise. Okay.
Yes,
So in
in
that
demand
case,
is
huh,
it's a clear space, like it's horizontal wise, it's a very big space. So and they need a same cooling effect to the all areas. So it's good for supermarkets.
so depend as per the application, as per the requirement. So here ductable split means I'm not talking about very big project. I'm just talking about the big project, not a high-rise building. Okay, and you see, taking the decision for the system is not just technical. We need to consider n number of parameters that we'll discuss
Yes,
at the time of machine
costing
this
and all
machine
this thing.
selection.
Mhm.
Okay, so you see, if you know the systems, all disadvantage and disadvantages, this will help you to take the decision at the time of selecting the system. So at this level,
Yes,
just focus on the system. Don't do any conclusion. In
yes, yes.
actual practice, the case is different. Okay,
Mhm.
sometimes technically one system is accepted, but because of the budget, we cannot consider that one. We need to go with the as per the budget. Okay, so just get the idea about the system. Taking the decision involve n number of parameters. Let me show you one. Let me play one small video clip, which will help you to get the clear idea about that ductable split. Still, if you have any confusion, and also we'll verify this in the drawing. Okay, so let me play this video first. Again, in the video, just focus on the concept. You'll find other options also. Ignore that. Try to understand about the ductable split. That's it. Let me play this. Find some vapor compression cycle and all. So what we already discussed. So you can just get the idea. But here the main concern is about the ductable split. So you can find here, this is a supply duct and this is a return. And you see this position of the duct in actual practice, we are not generally supplying the cool air from the floor. This concept is basically for heating point of view. Okay, so even the air distribution also don't do the conclusion. We have a separate topic for distributing the air. If you talk about standard, supplying the cool air from the higher level and supplying the hot air from the lower level, there is a reason. The reason we'll discuss at the time of topic air distribution.
The first step begins with setting your thermostat to the desired temperature. This
You see here what you can extract. This is split system is outdoor and indoor. This is the indoor below, and this is a duct. So we used to call ductable split. Just concept. Rest of the thing, you know, the cycle and all. The same thing you will find in the video.
triggers the condenser fan
repeating this, but only thing is how it is connected to the duct. That's it. Now, so let me show you one drawing also. In the drawing also, you can confirm this very easily. This is one drawing of a local project, belongs to Hyderabad only. Because as I said, now, most commonly you'll find ductable in India. So simply you can relate. You see, this is 11 TR 2 units. This one. And this 2 unit is connected to a box. This is called supply plenum. Again, these are related to air site. We have a detailed topic. Just I'm giving you an idea. This is called supply plenum. And this 2 AHU is connected to this box. And why we are using supply plenum, we'll discuss later. And you see, this is connected. This will connect to the outdoor. And in this case, 11 TR, remember, 11 TR means you'll find 2 outdoor, each of 5.5 TR in carrier. Similar case even in Blue Star also. If it is say less than 5 or 5.5 TR, you'll find 1 outdoor, 1 indoor. And above that, you see, and depend on model. You cannot take that as a specific in specific way. Depend on model. Okay, if you talk about carrier in Blue Star, for higher capacity unit, you'll find 2 outdoor, 1 indoor. 2 outdoor means 4 pipe is going to connect to 1 indoor. You'll find the 2 coils in this. There is a technical information that we'll discuss at the time of catalog based selection, mean machine selection. Just I'm giving the idea. So here is outdoor, 2 outdoor connected to 1 indoor, and this indoor is connected to a duct, and with this we are supplying the air. So we used to call this as a ductable split. So a version of split with a higher capacity, and we can provide the fresh air. Here also some units. And this is supplying the air through grills. It can be through grills or through the diffusers, etc. This is about the ductable split.